Welcome to my YouTube channel. In this video, we're going to look at the center of gravity. In physics, the main topic is mechanics. The topic we're going to look at the center of gravity. So the alternative term or the name we use for center of gravity is center of mass. You can use this center of mass. It actually means one and the same. Okay. Just mean bit. Here we go. Okay. So now we're going to look at. So by the end of this video, you know what center of gravity is, and an experiment you should use to determine the center of gravity, how to determine the center of gravity of an irregular object, and we're going to look at stability and what is stability and what is equilibrium, types of equilibrium, and factors which affect stability and center of mass and equilibrium as well. So hope you find this video of great help. Okay. So moving on to the topic. So center of gravity of an object is the point through which its whole weight appears to act. So this is the definition right here of center of gravity. This is the point through which its whole weight appears to act. Another way you can define center of gravity is by saying center of gravity can also be defined as a point within an object where its total mass seems to originate from. That's another way you can define what center of gravity, a place where all the mass of an object is seemingly to be originating from. So we must define what is center of gravity. So an experiment here, you can use an experiment here. I'll make a video on the experiment on its own, practical rather than just reading out these instructions. Okay. So moving on to stability. So what is stability? The ability of an object is defined as the ability of an object to regain its original position after it has been displaced slightly. So when you push a curve for an object, if an object retains its original position, then the object has what? Stability. For example, you kick a ball, the ball slightly moves back and then back into position. You can say that ball does what? Does stability. So moving on, stability can also be defined as a condition in which an object is not moving or not what? Falling. That's the definition of what? Stability. And define it as a way whereby the object is not moving, it's not also what? Falling. That's what we call what? Stability. Something stable is an object which not easily fall when slightly pushed or tilted. Something unstable is an object which can easily fall when slightly pushed or tilted. So now let's look at the condition of the factors that affect what? Stability. Number one, you need to have low center of gravity. Number two, see how wide base is of that object. So now, how does the low center of gravity affect the stability of an object? Well, the position of center of gravity affects the stability of an object. The center of gravity should be as low as possible. So, meaning that in order for an object to become stable, what you need to do is make sure the center of gravity is what is low. That's when the object is what is stable. But if you see center of gravity high, then that object will be what is unstable. When pushed, it will fall, or when tilted, it will fall. So moving on, white base. How does white base affect what? The bit of an object. So the base area should be as large as possible. Why? The wider the base, the most stable object will be. The mass of object should be concentrated to at the base concentrated at the base. So now moving on to equilibrium. So what does it mean when you say equilibrium? So equilibrium is a condition of an object in which the sum of all forces acting on it is what? Is zero. All the forces acting on object are the sum of all the forces acting on object are what? As zero. E.g. the resultant force is what? Is zero. Okay. So what I'm trying to say here is that let's say you have a piece of rock here, a box, right? And you apply a force in this direction. Let's say put my drone there. Try to put an arrow. Let's get my arrow. Okay. So you have my arrow there, right? You can see the arrow. Now let's give him this side as well. Arrow there. Okay. Let me just use this one for better one. I have this one. Okay, bet you have 20. You can apply force in the direction. Looking at this side as well. I have also what? 20 into spin applied on that direction as well. Meaning that this object is the result of force of this box. How would it be? Of this box will be zero. Why? Because the sum of the total forces acting on this one is zero. I said the sum of the result. How do you find the result of this one? You find the difference. If you say resultant, alright, equals to 2. This object you can simply say before the applied force is what? 20 and 10, right? Then subtract it. Backward force applied on the object is what? 20 Newton. When you do the calculations, you get 20 0. Hence, we can conclude that the object is what? Is equilibrium with 0 times equals what? 0 what? Newton. Obviously, here. Okay. So moving on. Objects which are in equilibrium are those that are stationary or at rest, those that are moving with constant velocity. That's what that's the main qualification for object to be not in equilibrium. So a stationary object can either be in stable equilibrium or unstable equilibrium or neutral equilibrium. Now I'm going to explain each and every type of these types of equilibrium. So this one, this type you have what? Stable equilibrium, which is this one. Stable equilibrium. So what do you mean when you say that an object is at stable equilibrium? So that to say simply that an object is said to be in stable equilibrium if when slightly pushed or tilted, it goes back to its original position. For example, look at this object here. If you push this one in this direction or you tilt it a bit, it will still retain its position. It applies to this triangle which is here. When you tilt it or push it, it will still go back to its original position. So this time when object goes back to its original position, when slightly pushed, it's said to be what? Stable equilibrium. For example, we may have let's say you have a cylinder there, right? And you just apply more force right there, which is in this direction. And then this object or the cylinder slightly moves a bit there. Then after you have moved it, pride force, which is this one. Then this cylinder returns back to its original position. Then conclude that this cylinder is at what? It's at stable equilibrium. Okay, so yeah, there. Okay, so the object above are more stable because they have number one, low center of gravity, number two, a wider base. And if you look at your setting, the base is much wider. And this center of gravity is what is very low. So these are the main two factors that affect what the equilibrium. So moving on, objects in stable equilibrium do not easily fall when slightly pushed. This is because the vertical line of a force from the center of gravity does not easily fall on the other side of the base. Now let's look at the stable equilibrium. An object is said to be in unstable equilibrium if, when slightly pushed or tilted, it falls. For example, it does not go back to its original position. Such examples are these objects you have here. For example, if you look at this triangle, of course, if you just apply force, let's say, in this direction, any amount of force in this direction, automatically this triangle would tip it. Just a little. Okay. Automatically, this triangle will tip over the 4. That's what I mean when we say object is what is unstable. Any amount or any applied force on it, object falls over. Moving on, the object above are stable because they are what high center of gravity and small and narrow base. Of course, if you look at the previous bases of those objects from looking, you will see that their center of gravity were lower compared to these objects which are in unstable equilibrium. That's the main causes of it. And equilibrium will not be what in an equilibrium. Now let's look at neutral equilibrium. Neutral equilibrium. So looking at the condition given here, we can safely conclude, we can simply say that an object is said to be in neutral equilibrium if it stays in its new position after it has been pushed or slightly tilted. So for example, we can give this ball here, which we have here. When you push this ball or you apply force in that direction, this ball of course move here, but the position where this ball will land, that ball will be stable. Either way, whether you pushed it or you did not, wherever pressed will land it to be stable. If it comes here, also here it be stable. If you move it aside, also here to be stable. That's the means neutral equilibrium. Same applies for a cylinder. When a ball is and then the cylinder are rolled, they come to rest in the new stable equilibrium. Otherwise, you need to note it's not here. Let me just show you this here. It's not advisable to put heavy luggage on the roof of the minibus because it can triple over at the corner when it's moving fast. For example, here this minibus, right? So now in this video, we have learned that for an object being equilibrium, number one, it needs to have a lower center of gravity. Lower center of gravity. That's number one. Then number two, it needs to have a wide base. That's how we put that this object is in a T in equilibrium. So now, if you analyze this new body, let's look at the log equation at the top here. This one. Zeta is codification for not in equilibrium. Okay, let's see it as a what? The base is actually quite large enough. Okay, how about the center of gravity? Center of gravity from the ground here, right? From the ground, the center of gravity is up there, up against my head there. So meaning center of gravity is what? It's very much high. So, so obviously this luggage we can conclude that let's see it may have the what? A big base, but it doesn't have the lower center of gravity. Hence it's what? Stable or static equilibrium. So how to modify this? We can set the modifications that should be made in the design of the bus here, or a bar to make it what? Stable. So like I'm explaining there, those two conditions need to be what? To be made. After you've done that thing, you're good, you're home and dry. So let's look at this question right here before I conclude the video. The diagram below shows two identical rectangular wooden blocks A and B. Block B has a layer of lead attached to its base. The blocks were tilted about edges PQ as shown in the diagram below. Okay, explain why A tops over at a smaller angle of tilt than B. Okay, so I need to explain when. Let's say push this soon, setting the shape object in this direction. Let's say in 20, yeah, 20 newtons, right? While the force in the direction. And then here, you see this. Like we explain why A tapers over at a small angle and then B. So you need to look at what the conditions, those two conditions, which are what low center of mass and wide the base. So if you look at the two objects given here, you see that this one, okay, this would be homework. Shouldn't be doing the work. These are lessons videos I should be doing the work, so you can try out and leave your answer in the comment section. Then I'll reply if the answer correct or not. Otherwise, thank you for watching this YouTube channel. Don't forget to like, subscribe, and share, and leave a positive comment.